Hello, we come again about asymptote. So in this video, I separate the exam type question from the lecture notes. So here we're focusing the exam type question, how the exam question looks like. So we have two examples here. The first one, example 29. Right, given the function f, 2x minus 3 over x minus 1, x plus 3. So find first the domain of f. Right, so below here, we know we have two values which is undefined. Okay, so let's see the solution. So we have two values which is undefined, that is x equal 1 and also negative 3. So apart from these two undefined, then it will be the domain. Okay, so the domain would be negative infinity until negative 3. Okay, the first one. So we change it into the ascending order, and then the next negative 3 until 1, and then lastly 1 until infinity. Okay, and then next the question asks about x-intercept. So x-intercept is when fx equals to 0. So here fx 0. So fx 0, we can find out the value of x is 3 over 2. Okay, because we this one multiply to the left side, it will become 0 straight away. So straight away 2x minus 3 equals to 0. Okay, so that's why we got 3 over 2 over here for x-intercept. And then for y-intercept, so y-intercept is when x equals to 0. So substitute x 0. So 0 minus 3 is negative 3. So this one negative 1 and also 3. So negative and also negative 3. So that's why the answer is 1. Okay, for y-intercept. Alright, next the question asks about vertical asymptote. So we know the function is undefined at negative 3. So we check one-sided limit as approach negative 3 from left. So from there we know that how do this one become negative infinity? Because this one is negative above here, and this one also negative, and this one negative 3 from left means that slightly larger, smaller than negative 3, which is negative 3.001. So plus 3 is still negative here. So overall we have 3 negative, so that's why the answer is negative infinity. And then next, for x approach negative 3 from right, so above here of course is negative, and then negative 3 minus 1 also negative, and this one so slightly greater than negative 3, so let's say negative 2.99. so when negative 2.99 plus 3, it is slightly positive 0. Okay, so that's why the answer, so we have only two negative here, so that's why the answer is positive infinity, right? And now when x approach negative 1, so I remove the sign here so you can see clearly. Okay, so when x approach 1 from left, we got negative infinity because so negative 2, so this one is positive. So below here slightly smaller than 1, which is 0.99 minus 1, so it is negative, and 1 plus 3 is 4, so we have only one negative, so that's why the answer is negative. And then slightly greater than 1, so above here positive, so below here slightly greater than 1 means that 1.001, so minus 1 is positive 0. So this one also positive, so overall is positive, so that's why we got positive infinity over here. Then after that we can conclude that the vertical asymptote is x equals 1 and x equals to -3. Okay, so remember you have to use one-sided limit from left and also from right for both values, that is -3 and 1. So means that total you have to do 4 one-sided limit before we can conclude the vertical asymptote. Right, next we want to find out the limit at infinity. So firstly, limit x approach -infinity. So we know this is a polynomial below here without the cert. So we just divide everything with x squared, because this is higher degree x squared. So divide everything with x squared. Okay. So after we divide, then we can simplify. So we notice that above here is 2 over x. So the constant is below here. So I think the answer would be 0. Okay, because the above already 0. So let's see what happens after we sub this one with 0, 0, 0, and 0. So that's what happened. And please, after we substitute with 0, please do not put the limit notation anymore like this one. No need, don't. If you put limit notation, you will penalize 1 mark. Okay, so just substitute and then we got 0. Just simple like that. Okay. Alright, next for x approach positive infinity. Well, you notice that we divide with this very similar thing, right? So I think we just do not go through very similar process. So we just write down it is similar to negative infinity. Minus 3, this one minus 3. Okay, just similar with the approach negative infinity. So we know that the answer is 0. Just like that. No need to go through very same process. At the end we got also 0, right? So straight away here we conclude that therefore the horizontal asymptote is at y equals to 0. Okay, just like that. So the rest, so this one, no need. Okay, no need this one. Okay. Okay, next for question 30. So this one we have set. So later we know that we want to find limit approach negative and positive infinity. It will be a bit different. Right, before that we go through if, state the domain, find the vertical asymptote. So this time no need to find out intersect. And then check the answer. The answer already given above here. Okay. So first, check the domain. So we know that below here it must be greater than 0. So as write down here, and x squared minus 9 is a quadratic, right? So we factorize, it actually is a quadratic inequalities. Okay, quadratic inequalities. So for quadratic inequalities, so how we get this one? So actually we use graphical method. So we know the ZOF is -3 and 3, and we want to find out greater than 0. So the domain would be less than -3 or greater than 3. Okay, as stated here. So that's the domain. Okay, next for question B, we want to find out the vertical asymptote. So remember you have to find out one-sided limit. So since the function is undefined, greater than -3 or less than 3, so we have to check one-sided limit from left at x approach -3, and also one-sided limit when x approach 3 from right. So no need to find out limit other than that, because other than that the function is undefined. Okay, so as you can see, we just find out here the first one, here number 1, and here number 2. So here number, okay, so from left at x approach -3 and from right at when x approach 3. So here we got negative infinity, this one we got positive infinity. So we can conclude that these two line is a vertical asymptote. Okay. Alright, next we want to find out a horizontal asymptote. So before that, you have to find out limit x approach negative infinity. So don't forget, when x approach negative infinity, you have a negative here outside. Okay. And as I said before, we don't write like this, we just divide by x, and for above here we put a square root the whole thing here and negative outside here. Okay, so here no smaller set, so divide by x, so above here 1, and then here negative outside, and then inside here 1 minus 9 over x squared. So when x approach infinity, so this one will become 0. So write down 1 over negative 1. So that's why the answer is negative 1. And then for x approach positive infinity, so this one for positive infinity doesn't have negative, no negative. Okay. So a bit similar than this one also, except they don't have negative outside here. So since they don't have negative, the answer would be positive 1 lah. So maybe you can put a detail here. So 1 over, sub the values. So 1 minus 0. Okay. So that's why we got 1. Okay, so we have two values here. So don't forget to write down the conclusion. So therefore, we have two horizontal asymptotes. That is y equals to negative 1 and y equals to 1. So if you not clearly here, so I write down below here. So y equals to negative 1 and also y equals to 1. Okay, so we have two horizontal asymptotes for this function. Alright, that's all for now. Thanks for watching. Bye bye.